Why can ChatGPT ace your homework but your home robot still can't reliably clean the kitchen? The secret lies in two words: embodied AI. While traditional AI works wonders in the digital realm, embodied AI, robots that sense, move and act in our messy, unpredictable world, faces challenges on a whole different level. Most AI today lives in a neat, predictable virtual world. Their inputs are text or numbers. Their outputs are just more text or numbers. They never have to worry about a slippery floor, a missing mug, or a cat jumping in the way. But embodied AI is about more than just thinking or talking, it's about doing. Imagine telling a robot to make you a sandwich. It has to navigate your kitchen, recognize the bread, open the fridge, find the right condiments, avoid obstacles, and maybe even deal with your curious pet. Every home is different, every object has quirks, and every day brings new surprises. This is why embodied AI is so much harder. It needs to process a storm of information from different senses at the same time. It must see, hear, feel, and sometimes even sense its own body position just to pick up a cup of coffee. Unlike text-based models that can train on billions of lines from the web, robots learn from experience, one painstaking demonstration at a time. Each action, grasping, moving, placing, must be physically performed, recorded and repeated over and over. Gathering just one large dataset for robotics can require thousands of hours and enormous collaboration, like the OpenX Embodiment project, which brought together data from 22 different robot types and hundreds of thousands of real-world tasks. Could we just train robots in simulation? It helps, but there's a catch. The gap between simulation and reality is enormous. Simulators can't capture every detail of the physical world. The weird lighting, the unexpected obstacles, the slippery surfaces. Robots trained in the virtual world often stumble when they step into your home. That's why bridging the so-called sim-to-real gap remains one of the biggest challenges. Even with clever tricks like domain randomization or digital twins, no virtual environment is a perfect copy of reality. There's also the problem of demonstration. Large language models learn from vast internet data sets. Robots, by contrast, rely on real-world demonstrations, which are slow, expensive, and always limited. And if you want your robot to fold laundry, open a tricky door, or pour soup without spilling, you need even more nuanced, high-quality demonstrations. Simulated data can fill some gaps, but robots need real-world experience to master the messiness of life. The complexity doesn't stop there. Embodied AI must translate abstract instructions like "clean the table" into a long chain of specific physical actions, finding the right rag, identifying crumbs, applying pressure, moving objects out of the way, and so on. High-level planners can often break tasks into steps with impressive accuracy, but executing those steps in the real world is a whole new battle. According to recent research, even with excellent task planning, the actual success rate of real-world completion can drop dramatically, often because of small physical errors, unexpected variables, or hardware glitches. And real life is full of edge cases. If a robot makes a small mistake, the consequences are very real. It might spill hot coffee, break a dish, or trip over the family pet. Unlike text-based AI, where a wrong answer is just a harmless error, physical mistakes can cause damage. This means robots must be able to generalize, to handle objects, instructions, and environments they've never seen before. They need to reason about cause and effect, anticipate consequences, and even guess where missing objects might be hiding, like realizing a towel might be inside a closed cabinet, not just out in the open. The challenges don't end once the robot is working. Embodied AI must keep learning as the world changes. New layouts, new objects, new tasks, without forgetting what it already knows. This is called continual learning, and it's another hurdle that's much more difficult in the physical world than in cyberspace. Evaluating robot performance is tricky too. Every home and task is different, and there's no single test that can capture the endless variety of real life. And then there's the hardware. Sensors wear out, grippers slip, motors fail. No two robots are exactly alike, and every piece of machinery is another possible point of failure. Contrast that with software AI, which lives on reliable cloud servers, far from the chaos of the real world. Despite these mountains to climb, the future of embodied AI is incredibly exciting. Every small step forward in robotics is a leap toward truly intelligent, helpful machines that bridge the gap between thinking and doing. So, next time you see a robot struggling with a simple task, remember, it's not just being dumb, it's wrestling with some of the hardest problems in all of AI. If you enjoyed this deep dive, don't forget to subscribe, and tell us in the comments, what real-world robot skill do you wish AI would master next?